So hello guys, this is again the continuation discussion of the Module 4 discussion video in strength of materials. Alright, so in this video, this would be the final video discussion nagyud about Module 4 or about axially loaded members. And as what I have said in the previous video, we will talk here about thermal stress. So nara siguro ko'y additional information about principle of superposition, about statically indeterminate members. But the main point of this video is all about your thermal stress. Alright, so let's proceed. So in the last video, we have discussed, diba, about the principle of superposition using the load displacement relationship. Diba? We are going to cut a section, express the internal forces in terms of the unknown, and then relate that specific internal forces to the displacement, diba? And then that would be substituted to the compatibility conditions, right? Now that is in order for us to analyze statically indeterminate structures or members. So karon we will discuss about this another method. All right, this would be another method of superposition that is named as the force method. So force method is siya since we will be dealing with displacements, all right, not by internal forces, meaning ato i-relate si load with the displacement. Pero again, unlike sa atong previous nga i-discuss in the last video, di ba, mag-cut tag section, so meaning internal forces atong concern. But here, using force method is we are not going to use internal forces, meaning dili ta mag-cut og section, just pure effect of each external forces. Alright, so it is also possible to solve statically indeterminate problems by writing the principle of superposition. Now this can be done again, that is, di ba mo na itong giingon ganina, in the last video, that subdividing the loading into components, then algebraically adding the results. So this method of solution is often referred to as the flexibility or force method of analysis. So to show how this is applied, so maybe let's have some examples siguro, right? To make ang atong karon is we need to make the member determinate. All right, so muna itong purpose. For example, all right, sa kaning example, the same ni sa atong previous example in the last video, all right, using load displacement method. So this example is, the purpose here is we need to make, diba, indeterminate man ni siya because we have two supports. Diba, we have your upward man to, diba? Upward man to. So we have your AY here, we have your BY here. So in this case, ang atong member karon is indeterminate na siya. So the use of force methods, on saan nato paggamit ng force method, is we need to make, right? We need to make this member, alright? We need to make this member determinate. So unsa man nato paghimo sir, og unsa man nato sir bahimo nga determinate. Right? So, diba, we have used already your static, diba, rigid bodies. Therefore, dili na ito magamit si summation of moment is equal to 0. Diba? Dili na ito siya magamit. We have your summation of forces x is equal to 0, which is di gyapon na ito siya magamit. And then, ang ato ng makinahanglan diha is summation of forces y is equal to 0. So, we only have one equation. Now, there is, we have two unknowns. Kaya mo nang nahimo siyang determinate. Indeterminate. Now, to make this a determinate structure is we need to have one reaction because naratay usa ka equation of equilibrium. Therefore, we need to treat, for example, I'm going to treat AY as our, say we have to remove, alright? Para mahimo ning determinate is we have to remove one support, right? We have to remove one support aron mahimo ni siyang determinate. Nga naman, for example, if I'm going to remove AY, right, ako ni himuon nga ako siya tantangon ba ang support. So therefore mahimo ni siyang cantilever na siya fixed support diri and a free end sa babaw. Kay mawala naman ang support, di ba? Mawala naman ang support sa babaw. All right? Now, using your force method is we need again mo to ako giingon nga we need to make the member statically determinate by temporarily removing the redundant support. Kaya nga naman, duha mo guna sila ka-support, so dili nato siya ma-solve. So therefore, ang usa is dapat ato siya tangtangon temporarily, meaning ato na siya ibalik later. Alright? So magtangtang tag usa ka support and then mahimo na siyang determinate. Alright? So we have two reactions, di ba? We have your AY and we also have your BY. So we just need to pick one kay ngano man usa mo lagi naratay usa ka reaction. Say for example, si FA ako himuon nga reaction. Alright? So therefore FB, alright, atong BY matreat ni nato siya as load, dili siya support. Alright? So if ato ni drawingon ang iyang bag-o nga free body diagram, this would be a fixed support tapos free na sa babaw. Meaning kay ato magitangtang si AY, alright? Ato magitangtang si AY. And that is loaded by 500 Newton and then that is loaded AY. Meaning si AY karon is dili na siya support, external load na siya because again it is treated as redundant support. Alright? Gitreat na to siya as redundant support. Now in this case is if ato ni tangtangon si AY, alright? Ato tangtangon si AY, ato tangtangon si 500. This structure is statically determinate. 'Di ba? Kay one reaction, 'di ba? One equation. Okay, so gets na oy. Alright, so gets na. So by this, we can have this loading diagram. Kani siya, manan siya. Alright, kini nga loading diagram atong akong gipakita. So that would be the new loading diagram. Naatay fixed support sa ubos sa B, tapos naapod tay free end sa A. And then that is loaded with these forces. So to solve this problem is we need to use this set of procedure. Alright, so this is also the general procedure using force method. So this is just the same with the one that I have presented in the previous video. Diba, ang sa previous video is E-core, diba? That's ECR, so ECRA. So E-core, dire, the procedure would be correct. Alright, so you start from the compatibility condition, you go with the relationship between the displacement and the load, and then lastly is gamito na nimo si equilibrium equations. Alright? So first is compatibility equations. Develop an equation of all known displacements of the member, both final and individual displacements. And then relate internal force and deformation using the formula. Alright? So ato siya tagsaon ha. So compatibility conditions. So, develop an equation of all known displacements of the member, both final and individual displacement. So, how are we going to... Actually, na-solve na ni nato siya kaning example, diba? Na-solve na ni nato siya in the previous video. Pero, let's try to solve this again using this force method. So, compatibility condition. Again, you are going to understand, alright, what are the displacement that are known. Right, kabalo displacement na atong concern dire displacement. So since ato naman siya gibag-o, 'di ba? Again ha, ato na ni siya gibag-o, you are going to consider the new free body diagram. Katong ato nagihimo siya nga redundant force. We have your 500 Newton downward and we also have your AY that is upward. 'Di ba mo na ni ato na siya gi-change, wala na tay concern ni BY dire. Wala na gyud ta nag-concern ni BY. 'Di ba? I hope mo nakagets. Di ba wala na ako nasuwat direct reaction ni BY. Kaya again, I've treated this kay meaning kaning member that is fixed on other side and free on the other side. Determinate naman ni siya. Right? Determinate na ni siya. So ang purpose na ko karon is how are we going to solve your AY? Alright, again, if you are going to use force method, ang pinakauna nimo nga ma-solve nga force or nga unknown is the redundant force. Kung kinsa ang imong gihimo nga redundant, siya ang pinakauna nimo nga ma-solve. Alright. So, we already have your compatibility equation. So, man ni siya. Again, fix man, di ba, sa final, right? Ang final effect of this member, right? The final effect on this member is that fix maghapon ni siya, di ba? Wala man tayo i-change. Matawag yung ganina. If you are going to use superposition, dapat wala kayo ma-change. If fix na siya, right? If fix na siya, i-fix yun dapat na siya sa final. Kani is ako lang siya matagi yung ganina nga temporarily remove. Kay meaning ato siya gi-remove pero again the effect is ibalik gihapon na siya. Meaning ibalik gihapon na siya ang effect. Kung fix ni siya dapat fix gihapon ang iyang effect. Alright? Ato lang siya gi-remove pero dapat at the end fix gihapon ang iyang effect. So if this is fixed ang effect gihapon, dapat ang iyahang displacement of B with respect to A that is again dapat the same with 0. Right? That should be 0. Kaya wala man tayong movement diha, kaya that is fixed support. So nanatay compatibility equations. So second, relate the internal force and deformation. So how are we going to relate your internal force and deformation? Sorry, dili na ni siya internal force. Relate external. Sorry, that's an error. Relate external force and deformation. So since diri, alright, na naman tay forces, again ha, wala tay cut, dili na mag-cut og section diri, just pure external forces. Alright, so we have your pila to external forces, we have your AY and we have your 500 Newton. So for your 500 Newton, alright, for your 500 Newton is we can have the displacement of this one, diba? The displacement of your BC is equal to your 500 Newton multiplied by the length, which is 3,000, over, say, area and modulus of elasticity is constant. So therefore that would be equal to, alright, so that would be 1.5 times 10 to the 6th, or 1.5 million AE, diba? Now for the deformation of A to B, diba, naman siya sa tumoy, diba, nasa siya sa tumoy. So therefore the deformation of our A with respect to B, that would be equal to AY multiplied by what? That would be multiplied by the length, which is 5,000, over your AE. Therefore that would be equal to 500 AY over AE. Okay, so since we already have this, we just have to relate, right? Relate everything. Saan ba pag-relate? So, can you say deformation BC, diba? Kaning deformation BC, since this is compressive force, therefore this would be downward, diba? Your deformation BC, your B with respect to C is downward, diba? Paubos man na siya. Therefore, CA would also go downward by this amount, diba? That would also be the deformation of A with respect to B, diba? Nakagets? Right, so gets na lagi na. So if this would be go downward, diba? Since your AY, diba? AY is tension. Therefore birahon na po na niya pabalik babaw, diba? So therefore that would be positive. So that would be the deformation of your A with respect to B upward. Alright? And then based sa ato ang compatibility equations, which is kani, the total deformation of B with respect to A, that should be equal to 0. So therefore we can use this one, that your AY multiplied by 500 AE is plus the negative 500 or 1.5, diba? Negative 1.5 man eh. Negative 1.5 million or 10 to the 6th over AE, that should be equal to 0. So in this case, you can already solve your AY. So therefore your AY now would be equal to that should be, di siya 500 dapat, this should be 5,000 ay. Sorry. This should be 5,000 kay 5 meters man ni siya. So 5,000 ni siya. Dara 5,000 dili ni siya mao. 500 man eh. So this should be 5,000. All right? So that would give us AY is equal to 300 Newton, since Newton man ang ato analysis diri kaganina. All right? So 300 Newton, and if you can recall sa atong previous video, AY is again 300 Newton. So therefore sakto ni siya using your force method. Again, wala ta nag-cut og section ha, wala ta mag-cut og section, just external forces lang atong ginatreat. And again, si atong redundant support ato siya ginatreat as loading, right? And we are going to solve your AY. So moto nga ang kung kinsang imong whoever your redundant force is, siya ang pinakauna nato nga ma-solve. Then if nanakay number 2, right? If nanakay redundant force, of course, you can use your equilibrium equations. So develop the relationships of your forces using statics. So, since wala man tayo x and summation of moments, di ba? So, we can just use your summation of forces y is equal to 0. Assuming upward forces are positive, so that would be, let's make this as our upward, di ba? Upward man na siya. So, by, then plus 300 nga ay, then minus 500, of course, that would be equal to 0, and it will give us the value of your by, which is 200 Newton. And if you can recall, this is also the correct answer using the previous method. Alright? So, mamili na lang jud ka kung kinsa man imo, si Ecor or si Orec. Alright? So, depende gina siya nimo. So, again, ang kaning nga example 4.6, katong example 4.6 ato ganina, it can also be solved. You can go back, alright, sa atong equation, example 6 na ato siya sa video 4.2. So, sa equation 6, you try using force method. So, Ecor man to gamit ganina, di ba? Sa last video, Ecor man to siya. So, try to solve using correct. That should give you the same answer. Alright? So, let's proceed. Alright, so our next topic would be all about your thermal stress. Alright, so here we are going to discuss how to determine the deformation of a material under a change in temperature or thermal variation. Alright, so a change in temperature daw can cause body to change its dimension. So as what I have said in our previous discussion videos, alright, nga the temperature, it may cause, alright, it may always cause deformation on a body. So generally, kung ang temperature is mo increase, the body will expand, right? And also, if vice versa, if mo decrease ang temperature, mo contract po na siya. Mauna, I don't know if you can notice, alright, same sa ato ang figure below, kanana sa ato ang figure below. This is located sa ato ang mga bridges. Di ba natin mga putol, natin mga joints, di ba? Diya sa mga joint is nasa mga ipangbutang nga it's either metal, right? Nga yasay gani mo tingog pa gani na kung maagian, di ba? So, nani siya kasagaran makita sa atong mga slab bridges. So, gitawag din natin sila og expansion joints. So, usually ang ilaybot ang diha is rubber or anything, all right? So, that the purpose of that expansion joints is to provide space due to thermal expansion or contraction. So, kung mo expand ni siya, walay problema, di man kay kung imo gyud na sila itapad og diretso, mo expand na siya, magdikit na sila, so mas stress na pud ang ato ang slab. So that is why if naay space diha, napakay allowance if mo elongate, so magdikit sila, di sila exert nga force. Tapos if mo contract na pud sila, so they just go back to their original position. So yung ana, that is called as your expansion joints to cater the thermal to cater the deformation due to your thermal stress. Alright? So most of our materials, especially kanang mga homogeneous, katong anisotropic, so ako makailan naman siguro mo ana, kaya ako naman nag-isulti before about homogeneous and isotropic. So it has been found out from experiments that the displacement of the end of a member having a length L can be calculated using the formula. So that would be the delta or deformation due to temperature is equal to your alpha multiplied by your length multiplied by your change in temperature. So your alpha is the linear coefficient of thermal expansion, your L is the original length, and your change in temperature would be algebraic change in temperature. Meaning algebraic change gani, that would be the final temperature minus the initial temperature. So sayon na kani siya hinumduman nga formula because you just have to use the mnemonic alat. Alright? Alat yun na siya. Now, this formula, alright, kaning formula, this will also be used sa inyong surveying. I'm not sure if human na mag-discuss ani, but this formula will be used under the topic of tape corrections. Alright? Naman may mga sag corrections. You also have your, basta, daghang pa mo correction sa inyong tape if you are going to use field surveying. Alright? Sa taping nga topic. So, namin mga ipang-add nga tape corrections. So, usa diha is si temperature correction. Then you will use this formula. Because nga naman, ang imo mga tape nga gamiton sa surveying is usually made of steel. Alright? So, magamit ang steel tape sa ato ang mga field surveys. And then, the temperature, since steel man na siya, the temperature may affect the length of your tape. Now, if the temperature is too high, so init ra kaayo, your tape will be elongated, or kung ang imuhang sukod nga 5 meters, that would be too long. Alright? Kung nakasukod kag 5 meters, therefore, less than na siya sa 5 meters kay ni elongate pa ng imuhang steel. So, dapat imo to siya i-apply sa imuhang correction. And that is also true if the temperature is lower. So, kung mas bugnaw, if nakasukod kag 5 meters, therefore, your tape is too short. Dapat mulapas man na siya 5 meters because ni-contract man ang imuhang steel tape. Alright? So, that is how you are going to use your thermal stress and deformation nga formula. Now, na-note dire, the higher a coefficient of thermal expansion. Okay, so asa man niyo makita ng coefficient of thermal expansion, sir? So, if you are going to go back to your table, alright, sa imuhang table of mechanical properties of commonly used engineering materials, naa na siya makitaan sa last column. Yeah, last column. So, you can just pause the video, pangitaa dito kung naabag yun. So, that is your coefficient of thermal expansion, alpha. Ang iyang unit is 10 to the 6th over degrees Celsius. Okay? So, muna ang iyahang unit. 10 to the 6th per degree Celsius. Alright? So, na siya note diri, the higher the coefficient of thermal expansion is of a material, the more it will expand in reaction. So therefore, if you are going to go back to your alpha, your titanium, 'di ba? Your titanium siya ang pinaka-lig-on, meaning magtikataas ang temperature, gamay ra siya og expansion. Kaya nga naman siya man ang pinakagamay sa tanan steel, sa tanan metallic na nakalista diha. Sa tanan metallic, siya ang pinakagamay og coefficient of thermal expansion. So, kuha sa ang inyuhang table of mechanical properties because I will be talking that in this video. Alright? So, kuha sa kadali and then okay, so based ato ang atong table, right? I hope nga you are looking at it right now. Si titanium alloy that is T16A14V, na siya coefficient of thermal expansion that is equivalent to 9.4, 10 to the 6 per degree Celsius. Therefore, tungod kay siya pinakagamay og coefficient of thermal expansion, gamay ra siya movement. Mo na nga ang ato ang titanium is usually gamiton na siya sa mga weapons, di ba? Kanang mga kuan kay tungod lig-on kay siya. And sa nilang tanan pod mechanic is ang pinaka-weak pod or ang pinaka-paspas mahilis mo expand is si aluminum. Alright? So, if you are going to compare the aluminum and titanium at the same change in temperature is mas taas og elongation si aluminum. Alright? Muna ang gina-specify sa ato ang note. Now, si crystals daw tend to have the lowest thermal expansion coefficients because their structure is extremely uniform and structurally sound. So, therefore, maski mag-init-init, dili gyud na siya siguro dili siya mo-expand or gamay ra siya expansion. So that is the significant of your linear coefficient of thermal expansion. Okay? So we have this example. So to solve the normal stress, di ba? Ang ipatana dire is the A36 steel bar shown is constrained to just fit between two fixed points when T1 is equal to 30 degrees Celsius. Now, if the temperature is raised to T2, which is 60 degrees Celsius, now we are going to determine the average normal thermal stress developed in the bar. Now, in this case, to solve for answers, ang pangutan, di ba? Ang pangutan na karon diri is the average, the average normal stress. So, therefore, we need to solve your stress, which is equal to force over area. Now, no problem with the area since given naman ta that is 100 mm squared. So, now we are concerned with the force. Now, we need to cut a section here. That should be your F. Okay? That should be your F. Now, let's do the free body diagram. Wala, fixed support man ni siya, diba? Fixed support. So, therefore, tulok ka reaction supposedly, pero since wala man tay moment, wala po tay X. So therefore, we only have your by here, and we also have your ay here. Alright. So, mamili na lang ka. Mamili lang ka. It's either equal ba? Alright? Or correct ba? So, mamili lang ka. So, here, I will be using your correct. Meaning, I'll start with the, what you call this? We will start with your compatibility condition. So, we know that since the bar is constrained, diba? Constrained man siya. So, therefore, the final deformation should be 0. Diba? The final deformation of your A with respect to B, or the other way around, that should be equal to 0. So, correct ko ha. So, if I'm going to use correct, I will be using redundant. Himdumi lang, if that is correct, you need to treat redundant forces. Therefore, I'll be having this free body diagram here. That would be AY. Right? That would be my AY nga free body diagram. Siya lang usa ang loading. So, nanata dira. And also, we know that since natay change in temperature, we can have your deformation in terms of your thermal stress. And that would be your alat. Okay? So, medyo kuwang-kuwang tag space dire, we can just proceed sa ato ang solution. Okay? So, let's proceed. Okay, so siya. So we have this again atong gipangita karon is your stress normal, your normal stress that would be equal to force over 100 square mm. Now natay nahimo nga free body diagram ganina where this would be your point B. Natay AY nga downward because I am treating AY as a redundant force. Again, guys, I'm using correct. Alright? Correct. So, first is we need to do compatibility condition. So, again, pwede ba ninyo siya ma-solve using your E-core. So, you can just try that in your respective houses. Sure. Okay. So, again, AY is we are going to treat redundant. Then, for the compatibility condition is we know again that this is A. Since this is a fixed support, your displacement of A with respect to B, that should be equal to 0. So, that would be our first redundant condition. Then, first compatibility condition. So, mura man siguro na. Wala man tayo lain makitaan. So, now is we are going to relate all the deformations to our external forces. So, deformations na lang na siya. Deformations. So, what are deformations that are occurring on this member? Right? Kana nasa ubos na itong mga member. So, may itong mga mu-occur diha nga deformation. First is, that is the deformation due to your AY. Diba? Your redundant force. And also, the deformation due to your change in temperature. So, therefore, this would be alat. And this would be PL over AE. Diba? So, let's start with your AY. The deformation due to your AY or A na lang, at butang diha, that would be your AY. The length is 1 meter, right? So, the length is 1,000 meter. So, I'll be treating AY as Newton. My area is 100 square millimeter. And the E for steel is 200, 836 steel. That is 200 megapascal. Therefore, I'll just be storing this one. Right? Kaning a term, I'll be storing this to A. Okay, so whatever value nga naa ni A is naa diha, so you store that to A, so this would be our AY. That is the deformation of your force A. Now, for your thermal deformation, so alat, what is the alpha of your thermal, A36 steel? So you have just pause first this video and you look for the alpha of your A36 steel. Alright, so we will be giving with your alpha for A36 steel is 12 times 10 to the negative 6 per degree Celsius. Okay, so therefore this would be 12 times 10 to the negative 6. Your L, your original length is 1,000. And your change in temperature is final minus initial. So that would be 60 minus. That should be 60 minus 30. So that would be 30 degree Celsius. So therefore, this is per degree Celsius. So makancel gihapon na siya. So pwede rin ako, di na lang ako siya i-appeal. So that would be 30 degrees Celsius. So therefore, what would be my change in temperature due to thermal expansion? So that would be what? That would be 0.36, 0.36 mm. Okay, so we already have your deformation due to thermal stress. Alright, so since we already have your deformations, wala naman sa tayong deformations diha, we can relate these deformations to our compatibility condition. Mo magyud na, after nimo sa R mo balik, ang tanan nimo nga ma-solve sa R is mo balik ka dito ni compatibility conditions. Kasi mato compatibility condition, that should be the deformation of your A with respect to B, that is equal to 0. And again, that is equal to the deformation of your due to your force AY, alright, plus the deformation due to what? Your thermal stress. And again, please take note, since AY is compression, so therefore this would be a negative deformation or contraction. Tapos your thermal stress, since ni-increase man ang ato ang temperature, therefore this would be a elongation. Alright? So therefore this would be 0 is equal to your AY, whatever nga naa ni A, that would be negative AY, plus your thermal stress, that would be 0.36. Now we can have the value of your AY, which is equal to, that would be equal to 7,200 Newton. So since positive man na siya, therefore ato assumption is correct, that is compression. Alright, so we already have your AY, therefore we can now start solving for your stress. Ay, sorry, wala pa di ay. Let's start solving your, since what if the question is what is the reaction on BY? So nga to proceed sa ato ang last problem, which procedure, that would be your EQ or equilibrium equation. So therefore we are going to use your summation of forces Y is equal to 0, upward forces are positive. So therefore naman ta diri free body diagram ganina, di ba? So this would be a support, this would be upward, that would be your BY. So therefore summation of forces Y, we can observe that that should be AY is equal to BY, and that should be equal also to 7,200 Newton. Alright, so equal na sila using your statics. Alright, so since ang atong problem karon is mangita man ta sa normal stress, sa to siya. So your normal stress is just simply your normal stress of the bar is equal to the force divided by the area, which is 100 square mm. So since AY and BY is just the same, so baski asa imong gamiton pwede ra na siya. So that would be 7,200 divided by 100. So the answer would be in, makancel ni siya, that would be 72 megapascal. And that would be our final answer. Alright, so let's check if we have the same answer. Alright, so therefore our answer is correct. That is 72 megapascal. Okay. Sige na lang siya kasayon. Char. Okay, so let's proceed to our next example. So a 2014 T6 aluminum tube having a cross-sectional area of 600 mm squared is used as a sleeve for an A36 steel bolt having a cross-sectional area of 400 square millimeter. Now the temperature is when the temperature is T1, which is 15 degrees Celsius, meaning the initial temperature, diba? The nut holds the assembly in a snug position, such that the axial force in the bolt is negligible. If the temperature increases to 80 degrees Celsius, determine the force in the bolt and the sleeve. So since ni-increase man ang ato ang temperature, so you know already that the materials expand. Alright, so si aluminum o si A36 steel, they expand together. Alright? But then again, since they are, they are in snug position, okay, nakalak man yun si sleeve. Kailan sa sleeve, meaning, mo siyang tube, right? Mo siyang tube, gisuksukan og bolt, tapos gilak both sides by nut. So therefore, dili gyud man, ang ato ang sleeve is dili gyud siya tang. Meaning, nakahugot ra gyud siya sa ato ang bolt. Now, the problem is, what is the, pangutan na karon? Determine the force in the bolt and the sleeve. Alright? So, let's analyze this by detailed. Alright, so let's proceed to our solution. So, since the problem states nga sleeve na siya, so therefore top view ta. Since sleeve man ni siya, assuming circle na siya, no? Alright? The aluminum tube, so therefore this is a tube. Aluminum ni siya. This is aluminum. Now, since we are dealing here with thermal stress, so therefore we need the value of your alpha. So you pause the video, you solve for you look for the alpha of your aluminum 2014 T6. Okay, and again that is equal to 23 times 10 to the negative 6 per degree Celsius. Now after that one is we have a steel bolt. All right? A steel bolt na di siya sa sulod. So therefore, this is made of A36 steel. And we know that A36 steel has an alpha of 12 times 10 to the negative 6 per degree Celsius. And again, sa ako pag-ingon din sa surveying, especially if you are going to do tape correction, since your tape is steel, usually kaning nga value sa alpha inyong gamiton. That's 12 times 10 to the negative 6 per degree Celsius. So, wala lang. Share ko lang. Alright? So nanatay steel. So, we are going to analyze this one. Alright, so side view ta. The free body diagram of this is, since, okay, let's try to investigate your alpha. Diba? Your change in temperature is equal to 80 minus 15. That is equal to 65 degrees Celsius. Right? Sakto ba? 65. 65. So therefore, there is an increase. Now, sa ako pag yung ganina sa note ko ganina, the higher the temperature, right? The higher the change in temperature, the higher the linear coefficient of thermal expansion, mas dako siya og expansion. Therefore, right? Kung ang original na to nga form is 150. Alright? So this is the aluminum. And this is also the bolt. That is steel. Kung sila duha, initially, they are 150 mm. Diba? Initially. So, after the change of temperature, mas dako og, say, kani ato ang, mas dako og deformation si aluminum. Say, this would be our deformation of aluminum in terms of stress. Right? Due to thermal stress. Compare sa ato ang deformation sa steel bolt. Alright? Ngingon ani lang siya. This is the thermal deformation of your steel. Kanang blue. Diba? So, tungod kay may change on temperature, silang duha kay, unsa? Silang duha kay may elongate. Right? Pero again, kitungod kay mas dako og thermal expansion, coefficient si aluminum, mas dako siya og deformation. Right? Muna nga mas dako siya. Pero, again, sa ato ang problem, nakabutang diha, they are in snug position. So, nakalock yun na siya dapat. So, therefore, tungod kay mas dako, di ba? Tungod kay mas dako ni sila og mas dako og deformation si aluminum, but then again, ginalock man siya ni steel. Our final, so nga ha, akong magamiton dire is correct. My first compatibility equation is that the final deformation, alright? The final deformation of our, say, this would be our, the final deformation na lang, the total deformation of our system siguro ni siya, or basta kanang ilahang pair, the tube and the bolt, ang ilahang final deformation is mo ni mahitabo due to thermal expansion. Alright, ni-elongate silang duha. Pero since si bolt, right, kinakasnag position man ni siya, ang kaning expansion ni aluminum is dili ni siya maka full force nga naman. Again, naka-constrain ba siya? So therefore, ang iyahang expansion diri is dili na niya makuha tanan. Therefore, birahon na siya pabalik ni, itud na siya balik ni steel. Alright? That is the force exerted by your steel. Diba? Itud na siya pabalik. Then kani, tungod kay nang hingusog yun ni si aluminum, nga mo expand yun na siya, kani nga to ang deformation ni steel is mapun-an na po ni siya. That is due to your force exerted by the aluminum. Okay? So I hope na nakagets. Meaning, your aluminum, and then again, equal ni sila the final deformation of your aluminum, that should be equal to the final deformation of your steel. Now, this is the compatibility condition that we need. Alright? So, ato ang first compatibility condition. The deformation of your aluminum, that should be equal to the deformation of your steel. Okay, so I hope mo nakagets. Kaya again, snug position man na sila. So, dapat di na sila magbuwag. So, the same ilahang deformation sa aluminum o sa steel. Ano na AA? Right? Deformation of your steel. So, this would be our compatibility condition. So, let's proceed with our relate. So, how are we going to relate your forces to the displacement? So, ako na siya gidrawing dire. Meaning, the deformation of your aluminum is equal to positive, di ba? May elongate na siya. That is due to your alat. Diba? May expand siya due to your alat. Pero, gipabalik siya due to your L over AE. Diba? Meaning, ni-expand siya, pero gipabalik siya ni steel. Kitungod, gi-contract man siya gi-contract man siya sa ato ang bolt. So, therefore, this would be our first deformation. How about the deformation of your steel? That is simply, ni-elongate siya due to your alat, plus ni-elongate pag yun siya, tungod kay gitud pag yun siya ni aluminum. Diba? Gitud siya ni aluminum, so that would be your FAL multiplied by your length over your AE. Okay, so we have this relationship. So we just have to substitute everything. So this would be your A, that is 24 times 10 to the negative 6, 24, 23. 23 rather. So that would be 23. 10 to the negative 6 multiplied by the original length. That is 150 mm. Alat ha, pero change na siya. 150. The change in temperature is 65 degrees Celsius. So, minus the force exerted by our steel. The length is same gihapon, that is 150 mm over your what? Your area. What is the area of our aluminum? Nasa ubos, that is 600 mm. Then the E of your aluminum is pila E sa to aluminum? Nasa table pangita. That is 73.1 gigapascal, di ba? So that would be 73,100 MPa. Therefore, we can have this term, at na siya simplify, your deformation of your aluminum is equal to, so that would be equal to, ang kanina atong first term, that would be equal to 0.22425 minus, I'll just be storing these values, at ako siya i-store ni A. So that would A, then Fs. Okay, so nanata sa ato ang aluminum. Now, let's try to solve your steel. So, due to your alpha, that is 12 times 10 to the negative 6 multiplied by 150 nga length. Sorry. 150. Your change in temperature is 65 degrees Celsius plus your F aluminum multiplied by 150 over your area. The area of your bolt is 400 square millimeter, and that's A36, so that should be 200,000. All right, so that would be your deformation of your steel is simply equal to that would be equal to 0.117 plus ako na siya i-store ni B, whatever value nga naa diri, ako na siya i-store ni B. So B multiplied by our FAL. Okay, so mana siya. So if naana na sila, we are going to relate this one to our compatibility condition. So sa mga compatibility equation, dara, that the deformation of our aluminum, that should be equal to the deformation of our steel. Di ba mo na ito ang compatibility condition? So therefore, we have to equate these terms kani sila duha. Kaya equal naman daw kuno sila. So that would be 0.22425 minus whatever nga naa ni A multiplied by your F by the steel is equal to 0.117 plus BFAL. So, ako lang siya simplify. That would be your AFS plus BFAL is equal to, ako siya i-transfer sa pika side, that would be equal to 0.10725. So, this would be our equation number 1. So, asa man tayo lain naman tinakita nga equation kaganina. Wala na di ay. Wala pa man dito ng equilibrium. So, humanata sa R. Alright? Humanata sa R. So, therefore, proceed na ta sa ato ang third procedure, that is your equilibrium equation. So, we are going to use your static. Summation of forces Y is equal to 0. Kaya ato na himo og free body diagram kani nga figure sa ubos. Right? Ato na siya himo og free body diagram. Ang mahitabo karon diha is it would give us this one. Mubira si aluminum pababaw, right? Iyan na itud pababaw, FAL. Itud pod si sleeve ni bolt paubos. That would be your F steel. Di ba? So inana sila. Marabag mugawa si aluminum, mutod siya, pero ipabalik siya ni bolt. So that is why your summation of forces Y is simply your FAL is equal to your FST. Okay, so therefore, this would be our second equation, or your FAL minus FST is equal to 0. You can use mode 3 to, or pwede pag mag-substitute na lang kadiretso. That would be your, since equal naman daw sila, so I can just write your AFS plus BFS is equal to 0.10725, or your FS is equal to 0.10725 divided by your A plus B. So Fs, that will also be equal to your steel. So therefore, that is equal to, so that would be equal to 20,255.06 Newton. Alright, so since dako-dako naman siya, I'll just be expressing that as, Fs, puros Fs, aluminum, should be aluminum. Your F, aluminum, that should be equal to 20,000.25 or 26 kilonewton. Right? And that is our final answer. So, equal naman na sila. Okay? So, now let's check if we have the same answer. Right? So, let's check if we have the same answer. That is Fs is equal to B. Anong B? Your steel should be equal to your aluminum. That is equal to 20.30 kilonewton or 26. The same lang gihapon na siya. Okay, so therefore, our answer is correct. Okay, so let's proceed with our next example. Okay, so that is the last example for this module. And again, that is the last also example for this video. So therefore, you are now ready for your assessment number 6. That is on Wednesday, 12 noon. So June 2 na siya. And then closing would be Thursday, 6 a.m. So the coverage would be your video 4.2 and your video 4.3, which is this one. So katong 4.2, which is all about statically indeterminate members, and then video 4.3 is all about your thermal stress. Alright, so I guess mo lang siguro na siya, and also that is the end of our module 4. So therefore, next week or the second week of June, maybe, that is we're going to enter your module 5. Alright, so problem set 4 will be released soon. So also prepare for your long examination 4, that is again on Friday, June 4 until June 5 or Saturday, 12 noon. So that would be open for 24 hours. So no reason nga dili makatake sa 4 to 5 hours na exam. Alright, so the coverage would be module 1 to module 4. Alright, so thank you so much for watching, and I hope nga nakagets mo. And if you have some questions, feel free to send me an email, and then let's answer that. Alright, so after your long examinations. If importante, so before your long examinations. Alright, so thank you, and see you on our next video.